Welcome to the last lesson of Unit 5. I've actually kind of already referred to this before, back in Lesson 2. You probably don't remember it, but I did. So, if the similarity ratio of two similar figures is A to B, then the ratio of the perimeters is also A to B. And the ratio of their areas is A squared to B squared. Now, I'm going to take some time here and show you what I mean by that. I'm going to draw a little right triangle here with side lengths 3, 4, and 5. Let's say I triple the side lengths. Okay. So if I triple them, 3 times 3 is 9. 4 times 3 is 12. 5 times 3 is 15. Okay. The perimeter of the small here would be 3 plus 4 plus 5. So 3 plus 4 is 7, plus 5 is 12. And the area would be 3 times 4 divided by 2, right? 3 times 4 is 12. 12 divided by 2 is 6. Over here on the bigger one, the perimeter would be, well, 9 plus 12 is 21. 21 plus 15 is 36. The area would be 9 times 12, which is, what is 9 times 12? 108 divided by 2 is 54. We're like, okay, great. What's the big deal? Well, let's look at a corresponding side. So 3 to 9. If I want to get a similarity ratio out of that, that would be reduced to be 1 to 3, right? 4 to 12 would give you 1 to 3. 5 to 15 would also give you 1 to 3. So the similarity ratio, which I'm going to abbreviate SR, the similarity ratio would be 1 to 3. Let's look at the perimeters now. So 12 over 36, reduce that. What do you get? You get 1 over 3, right? Same as the similarity ratio. So the ratio of the perimeters is equal to the ratio of the sides. Now let's look at the areas, though. 6 over 54, that is not 1 over 3. If I reduce that, I can take 2, or actually I can take 6 out of both. 6 divided by 6 is 1. 54 divided by 6 is 9. Well, that's not 1 over 3, but what it is 1 squared over 3 squared. What's 1 squared? 1. What's 3 squared? 9. And that is where these two things came from. Okay. Now we're just going to use that for some practice problems. I'm telling you the trapezoids are similar. That is key. You need them to be similar. If they're not similar, none of this applies. What is the similarity ratio? Well, it's 6 to 9. Well, 6 to 9 reduces to what? 2 to 3, right? So using what we just talked about a little bit ago, what is the ratio of the perimeters, or what is the perimeter ratio? It's equal to the similarity ratio, so it's also 2 over 3. What is the area ratio then? Well, you take the similarity ratio and you square both top and bottom. So 2 squared is 4, 3 squared is 9. Okay, that's it. Now, you're like, oh, that's easy. Nothing hard there. This is what you're going to have to do mostly right here. Okay, I'm telling you that they're similar again. Again, important. The area of the smaller pentagon is 30 centimeters squared. Find the area of the larger pentagon. If you're finding an area, you need the area ratio, which I will abbreviate AR. What do you have? In this case, what are you given? You have two sides that are corresponding, so you have a similarity ratio. So that's 4 over 10, which reduces to 2 over 5. Well, how do I get that into an area ratio? Well, I have to square both the top and the bottom. So I get 4 over 25. Now, what does that mean? That means if the area of the small one is 4, then the area of the large one would be 25. Now, the area of the small one is not 4. The area of the small one is 30. Well, 30 over what is going to reduce to 4 over 25. That's where our proportion comes in. I need to use 4 over 25 equals, and 30 was with the smaller, so it's going on top, over x. So I get 4x equals, I get 750. Divide by 4, and you get 187.5 centimeters squared. What I will see most people do and mess up big time on this one is they will say 2 over 5 equals 30 over x. If you do that, you're not getting any points. You're not getting the main idea here. You have to switch it to an area ratio in this problem. Okay, next example. Oops, something happened there. I'm going to do that. Next example. The corresponding sides of two similar decagons are in the ratio of 3 to 4. Given that the area of the larger decagon is 96, what is the area of the smaller decagon? So again, we're finding area. We need an area ratio. What did I give you? A similarity ratio. I gave that to you. It's actually easier than the last one. So 3/4 is the area ratio. By the way, doesn't matter what shape they are, as long as they're similar. They could be similar 29 gons. I don't care what they are, as long as they're similar. Okay, so 3/4 is a similarity ratio. How do I change it to an area ratio? Square both top and bottom. So that's 9/16. That's my area ratio. Now I can use that to set up my proportion. So 9/16 equals, now make sure you put 96 in the right spot. 96 is the area of the larger. So larger on this one is on the bottom, the way I set it up. Okay, so 16x equals whatever that is. Type in the calculator real quick. I get 864. Divide by 16. And I get 54 inches squared. Okay. Now, in both of those examples, we went from a similarity ratio to an area ratio. This one, I'm giving you two areas. So I'm giving you an area ratio. I want you to find the similarity ratio. So the area ratio is 98/50. Okay. How do I get back down? I always say back down to a similarity ratio. Well, if I have, this is like a squared over b squared. And I want a over b. So how do I go from a squared to a? Square root, right? Now you're looking at that, you're like, oh, square root of 98 is not a good number. Square root of 50, not a good number. Correct. It's not. Good idea is to reduce if possible. So reduce this. Take 2 out. What's 98 divided by 2? 49. 50 divided by 2 is 25. Reducing, this is still an area ratio. Reducing doesn't change the type of ratio you have. Now I still have to take the square root of both, and I get 7/5. That's the similarity ratio, which means it's also the perimeter ratio. Right? The areas of two similar parallelograms are 1875 and 135. So we'll see exact same problem, just bigger numbers. Well, they both end in 5, so I know I can divide them by 5. Go ahead and go to your calculator. 1875 divided by 5 is 375. Not liking that number a ton. 135 divided by 5 is 27. Not liking that number a ton. Let's see if I can divide by 3. I know 27 divides by 3. That's 9. 375 divided by 3 is 125. This is still an area ratio. I haven't changed the type of ratio because I haven't taken the square root yet. Now I need to take the square root of both. The bottom's nice. Square root of 9 is 3. Square root of 125 is not nice. You need to break it down. 25 and 5, 5 and 5. Which gives me 5 radical 5 over 3. And that's the ratio of their sides. Okay. Last one. The areas of two similar hexagons are 324 and 64 centimeters squared. Assume the perimeter of the smaller hexagon is 26 centimeters. What is the perimeter of the larger hexagon? So we're looking for perimeter. We need the perimeter ratio, which if you want to write this down, you can. That's the same as the similarity ratio. So we need that. What do I have? I have an area ratio. What is it? 324 over 64. Okay. Reduce 324 divided by 64. Not a great number. So 324 divided by 8. Nope. 324 divided by 4. There it is. 81. 64 divided by 4 is 16. Now I take the square root. So 81 to square root is 9. 16 square root is 4. Now I have a similarity ratio and my perimeter ratio. So that means if the perimeter of the large one was 9, then the perimeter of the small one would be 4. Well, the perimeter of the small one's 26. We don't know what the large one is. So 4x equals 234 divided by 4. You get 58.5. Perimeter is just in centimeters, so 58.5 centimeters. Okay, that's it for this lesson. That's it for this unit. So test will be coming up soon.